You could say Robert Connor has a thing for bridges. He's obsessed with how they perform under stress. And at Purdue University's gigantic Bowen lab, he gets to play with them to his heart's content.
You know, having this facility is just a great big sandbox for a guy like me to play in, really. You know, we get to test all different kind of things. We come up with new ideas on how to test things.
Bowen Lab is just one of a handful in the world where engineers get to test full-scale structures. Say you need to know just how hard the hardened concrete of a nuclear reactor should be, or the ability of a highway light tower to sway in storms year after year. Well, here at Bowen, they can safely yank one of those towers back and forth until it cracks. But today, on center stage, Connor set up a 12-meter long, 8.5-meter wide chunk of highway bridge. On it, he's got 2 axles loaded down with the same weight a tractor-trailer carries, about 20,000 kilograms. To move the truck down the road, he's harnessed a pulley to one of the lab's twin 30-ton overhead cranes.
What we do is we roll this back and forth and produce the same effects that you'd have in a real highway bridge, but we can do it here in the laboratory in a controlled way to understand how the load interacts with the structure.
Inside and underneath the bridge are about 200 sensors. Strain gauges that track how the bridge's steel and concrete stretches and compresses as it takes the truck's weight.
And every one of these little wires you see, every one of these locations, corresponds to one of our sensors that we've installed within the concrete or on the steel, or even right here on the main girders.
A laser tracks the truck's exact position. A steel rail keeps it moving in a straight line. By shifting the position of the truck from one edge of the bridge to the other, they construct a full portrait of how the bridge twists and bends under pressure.
And that really allows us then to see the effect of this heavy truck on the steel and on the concrete. We can understand then the behavior, how this, in real life, how will this thing react. We can then take that data and compare it to computer models, and it allows us then to improve the safety of bridges, the reliability of bridges, and the durability of bridges so that we can have a better infrastructure that'll last us through the decades.
Under the bridge, a bit like trolls, Connor and grad student Curtis Schroeder camp out and monitor progress.
There's kind of a global effect in the bridge, the total weight of the truck on the bridge. But if you imagine the concrete that the wheel drives over is directly loaded by that tire, by that axle. And because of where we have the sensors positioned, we're able to see that. So the truck is almost right above our heads at this point, isn't it?
Now we're going to start to see the local effect.
The change in strain is quite a bit because the wheel is passing directly over that spot. See how the slope is getting steeper? That's because the wheel is directly loading that location on the bridge. And frankly, that's actually what can cause some of the damage in these bridge decks, is these local, very quick changes of strain that are very large.
But at the end of the day, it's tough to keep a structural engineer in the lab.
What we do in the laboratory is only part of the story. What we like to be able to do also is go out into the field, install sensors and various type of monitoring devices on bridges and buildings, and monitor how they perform over time. Really, our objective is to let those structures tell us how they respond in the field.
So that he can hit the road in style, Connor and his team have a custom-rigged mobile lab.
Here, in the front half of the vehicle, we have our mobile office. This is really an extension of what we have in the laboratory, taking it out into the field. It allows us then to have our computers hooked up so we can look at data in real time. In the back half of the van, we have all of our equipment, everything we need to do a test out in the field. And very importantly, it allows us to respond very quickly because the vehicle is always stocked with this equipment. So when an owner has maybe an emergency of some kind, we can be on the road in 15 or 20 minutes after receiving a phone call. One of the things that's critical with respect to the infrastructure is not only do we want to be able to have new materials and new designs, that's forward-looking, but we also have to remember that, most of our infrastructure, whether it's highway bridges, railroad bridges, are old.
So far, the bridge in Bowen Lab is in perfect condition. In fact, Connor's been asked to donate the lab bridge to a new road that's under construction.
Most of us got to work today on an existing concrete or maybe even a riveted steel bridge. We can't forget about that part of the infrastructure. We have to make sure that that's still there and performing for a long time for us.